I just quickly, I think this is the previous one. Cut it and just and check. Can can you hear me? Can we all see the board? Can we see the board? Paul, can you see the board? This one is short. Well, can just the cloud, just lower the volume. We don't know the one more on the same day. In fact, we did half of the one. So I shouldn't even touch on it. But let's just play that. So now what's the next question? And 5 over 4, right? And theta over 2 equals to 1 minus sin theta over what? 1 plus sin what? Sin theta. So we have to show that this left side is equal to the right side, isn't it? So, like I said, we are familiar with this identity. Tan A minus B equals to what? Tan A minus tan B divided by 1 plus tan A tan B. We are familiar with this identity, isn't it? Tan A minus B equals to tan A minus tan B over 1 plus tan A tan B. So we are assuming now that our A is 5 over 4 and our B is what? Theta over 2. Therefore, tan B squared, the question has square, right? So let's forget about this square now. Let's apply something like this first. So tan theta over 4, tan 5 over 4 rather, minus theta over 2 equals to what? Tan 5 over 4 minus what? Tan theta over 2. I'm not dealing with the right hand side for now. We are not touching it. We are only touching this until we transform this guy to this guy. So we are not touching this at all. So if tan A minus B equals to tan A minus tan B over 1 plus tan A tan B. So tan 5 over 4 minus theta over 2 equals tan 5 over 4, just like tan A minus tan theta over 2 minus tan B over what? 1 plus tan 5 over 4 tan what? Theta over 2, isn't it? And we know that 5 over 4 is what? 45. 45 is minus. What's tan 45? 1. So this guy gives us what? 1 minus tan theta over 2 divided by what? 1 plus what? Tan theta over 2. So this one will give me 1 times tan theta over 2. So tan 5 over 4 is 1. 1 times tan theta over 2 is get tan theta over 2. Is it clear to that part? We all know that tan is what? Sine over cosine, right? Sine over cosine. Therefore, 1 minus tan theta over 2 is going to give us 1 minus Sin theta over 2 divided by what? Cos theta over 2. Because if tan is sine over cosine, divided by what? 1 plus sin theta over 2 divided by what? Cos what? Cos theta over 2. What's the next thing we are going to do? Oh, sorry, apply that square. So the question has square. So now let's go up. Let's square it. Let's square it. If this is actually tan pi over 4 minus theta over 2, then tan square pi over 4 minus theta over 2 is going to give us what? The square of this as well, isn't it? So now if you square this, you have and that square is from this part, but there's no problem. It's not a big deal. So if you have a minus b all into square, you are going to have what? A square minus 2ab plus what? B square. So this we have seen that our 1 here is a and our b is what? Sin theta over 2 over cos theta over 2. So here we are going to have 1 square, which is 1, minus ab, 2 times 1 times this, right? Going to give us 2 times 1 is 2. We are going to have 2 sin theta over 2 cos what? Theta over 2 plus b square. If you square this, you are going to get what? Sin square theta over 2 divided by what? Cos square theta over 2 over x. I said by 9.5, not message me. What's that? Thank you for your money. After we went school, I didn't tell them for just simply stuff. You have to look at them and you don't have to do like everyone. Do you guys this part? Can we continue? So here we have seen we have the same thing as the numerator as the denominator. The difference is just this minus and plus. So we just write the same thing. Now we have plus, right? 2 sin what? Theta over 2 divided by what? Cos theta over 2 plus what? Sin square theta over 2. Yeah, divided by what? Sin square theta over 2 divided by what? Cos square theta over what? Over 2. Is it clear to that part? Now we are checking at the right hand side. The right hand side determine what we are going to do next. So because my right hand side look like this, what is the gap this guy inside this guy? If I divide everything by cos square theta over 2, are we together? I cannot be divided by sin square theta over 2 because if I try it, it's going to be complicated because the denominator will now contain sine and cosine. I might complicated, but if I divide everything by cos square theta over 2, this guy will go, this one will go, this will go, this will go. So I'll have something like sine everywhere. So I'm good to go now. Multiplication rather, not division. Multiply the numerator and just multiply everything by 1. And I can write 1 to the what? Cos square theta over 2 divided by cos square theta over 2, isn't it? Is this not 1? So I want to multiply. So if I multiply everything by 1, I'm not changing. But I want to write my 1 in form of cos square theta over 2 divided by, I have what? Cos what? Square theta over 2. Let me just put dots here. So I'm multiplying both the numerator and the denominator by what? Cos square theta over 2. Is that clear? Is that clear? So let's put this in brackets. So if I said cos square theta over 2 times 1, cos square theta over 2, cos square theta over 2 times this will cancel 1 out of it, right? So we now have 2 sin theta over 2 cos theta over 2, isn't it? So 1 minus 2 sin theta over 2 cos theta over what? 2. This times this we cancel this. What are we going to have left? Sin square theta over 2 divided by cos square, same thing we have here. The difference will just be this time. 2 sin theta over 2 cos theta over 2 plus what? Sin square what? Theta over 2. Is it clear to that part? Any question? Let's get very well. Ask your question. Is it clear? Which part? Okay, I'll just try to just ask a question. When yeah, this times one we have to multiply it inside the bracket. This times one we have to this time no we only have one. We cancel one out of this. Then I have 2 times theta over 2 cos theta over 2. So it's like you are saying 2 you get 2 sin theta over 2 divided by cos theta over 2 multiplied by cos square theta over 2. So this remove and have everything at the numerator. You get like that. Any question? Let me check. Okay. I'm sorry. I will try not to write that part. Let me just. You know what? For the sake of, let me see these people. They are frustrating me. Let me just cut it from this. You have to be repeated. My writing is very bad. I think I have a better way of writing this. Don't worry, if you have written it, just put it down. We are still going to write it. I'm going to manage the board and yes, be able to solve everything without saying the board. Now let's start with it. Sorry. Now if you don't understand the rest, you just listen now. Tan 5 over 4 minus theta over 2. Show that it's equal to 1 minus sin theta over 1 plus sin theta. Then now then you can see the board. Now for the right hand side, for the right hand side, tan square rather. For the right hand side, that is tan square 5 over 4 minus theta over 2. Now note tan A minus B equals to A minus tan B divided by 1 plus tan A divided by 1 plus tan A tan B. So that means tan 5 over 4 minus theta over 2 should give us what? Tan 5 over 4 minus what? Tan theta over 2 divided by what? 1 plus tan 5 over 4 tan theta over what? Over 2. Now let's square it so that we can have it as this. Now square both sides. Square both sides. So this one is going to give us tan square 5 over 4 minus what? Theta over 2 equals to. So this is already one, Abi. This one just let me write it first. This one gives us tan 5 over 4 is 1 minus what? Tan theta over 2 divided by what? 1 plus what? Tan theta over what? No, this tan 5 over 4 is 1. 1 times this will have this back, isn't it? So now let's start like now. 1 minus tan theta over 2 divided by 1 plus tan theta over what? Over 2. Now if we square this, we must also what? Square this. Now what are we going to get next? We are going to have, so this tan square 5 over 4 minus this is already do, so we don't need to write it again. Now if you square it there, this is like a minus is going to give us a square, that's 1, right? Minus 2, 2 times 1 times this, we have 2 tan theta over 2, right? Plus b square. B square is we have got tan square theta over 2, isn't it? Divided by 1 plus 2 tan theta over 2 plus what? Tan square what? Theta over 2. Is it clear to that part? It's clear there. Yeah. So now note tan equals what? Sine over what? Over cos. So we are going to change all these tan to cosine. To sine and cosine, function of sine and cosine. So these guys give us what? 1 minus 2 sine theta over 2 divided by what? Cos theta over 2 plus what? Sine square theta over 2 divided by what? Cos square theta over 2. Sine square theta over 2 divided by cos square theta over 2. Everything over 1 plus 2 sine theta over 2 divided by cos theta over 2 plus sine square theta over 2 divided by cos square theta over 2. Do we get it that? Oh, do we get it to that part? Do we get it to that part? Okay. It's already showing. Can we proceed? We can, right? Like I told us, we are going to multiply 2 by cos square theta over 2 divided by what? Cos square what? Theta over 2. So we use all the numerator to multiply this one. Use all the denominator to multiply this one. 1 times cos square theta over 2. That's what? Cos square theta over 2, right? Minus this multiplied by cos square theta over 2. This one will remove 1 out of this. So we now have cos theta over 2 left here. Cos theta over 2 times 2 sin theta over, this one is already cos. So like cos square theta over 2 over cos theta over 2. So this one will go. We only have one of these left here. So 2 sin theta over 2 times cos theta over 2 give us 2 sin theta over cos theta over what? Over 2. This is square. Square we have square theta over 2 left here. Plus what? Theta over 2 divided by same denominator plus what? 2 sin theta cos theta over 2 plus what? Sin square what? Theta over 2. Is it clear to that part? To make it bigger, right? I know they will give us problem. I will delete it now. Is it clear to this part? So now let's combine these two together. So here we have what? Cos theta over 2, cos square theta over 2 plus what? Sin theta over 2 minus 2 sin theta over 2 cos theta over 2 divided by cos square theta over 2 plus sin square theta over 2 plus what? 2 sin theta over 2 cos theta over 2. Is it clear? I join this first and last together. We know trig identity, this guy equals to 1, isn't it? It's not necessarily it must be theta, just that the two angles must be the same. So like sin square theta plus cos square theta is 1, sin square x plus cos square x is 1, sin 1 over x plus cos square 1 over x is also 1. Once the angle are the same, is 1. So since this is like the identity, so here we have 1 minus. Now before then, note, okay, let me write it out. Note cos square theta over 2 plus sin square theta over 2 equals to 1, and 2 sin theta over 2 cos theta over 2 equals to what? Sin theta. I hope we know this. Okay, the one we are familiar with is 2 sine theta, sine 2 theta equals to what? 2 sine theta cos theta. We remember this, abi? But if you divide the whole angle by 2 over 2 over 2 over 2, this one 2 will cancel 2, we have sine theta left, right? Right? So now we now have sine theta equals what? 2 sine theta over 2 cos theta over 2. That's where we have this. 2 sine theta over 2 cos theta over 2 equals to sine theta. Do we get what I did? Do we get what I did? You know, we are familiar with sine 2 theta equals to 2 sine theta cos theta. Now all the theta divided by 2. This sine 2 theta will now remain sine theta, which is this. All these 2 sine theta cos theta will now become 2 sine theta over 2 cos theta over 2. So sine theta is equal to 2 sine theta over 2 cos theta over 2. If you want to turn it back to this, multiply the angle by 2. We have sine 2 theta equals to 2 sine theta cos theta. So that's that for that. So now at the end of the day, since this guy equals to 1, we have 1 minus what? Sine theta over what? 1 plus what? Sine theta. So that's the proof. Is it clear? Check from the beginning. From where? Here we multiply. See, we multiply everything here by cos square theta over 2. So cos square theta over 2 times 1. We have cos square theta over 2, right? Cos square theta over 2 times this. This like cos square theta over 2 times 2 sine theta over 2 cos theta over 2. 2 sine theta over 2 divided by cos theta over 2. Like if you multiply this by this, I've written it out. No, this one we cancel 1 out of this. We now have cos theta over 2 times 2 sine theta over 2. Now give you 2 sine theta over 2 cos theta over 2. Now check this again. Cos square theta over 2 times sine square theta over 2 divided by cos square theta over 2. This one is square and this is square. All this we cancel this. You have sine square theta over 2 left. Same thing, the one at the down here, use it to multiply all this one again. Just like the one we did, you also get this. So here now, just pick these two together. Let this one stand alone. Pick this first and the last together. Let this one stand alone. Since this guy is 1, then this is equivalent to sine theta. This guy is 1, this is also equivalent to sine theta. Is it clear? Okay, let's write it before I clean the board. Let's write it. How are you? Okay, you are Paula. This thing is go to WhatsApp now. Go and tell others to join us because I cannot call the video again to go and be chatting on WhatsApp. Where? Last part. Show this or this. This. Note cos square theta. This one are easy. If we have, let me. You know, sine 2 theta equals to what? 2 sine theta cos theta, right? Now divide all the angle by 2. Divide all the angle by 2 over 2 over 2 over 2. What will this one become? Sine theta, right? Abi? Equals to what? 2 sine theta over 2 cos theta over 2, isn't it? So since this is 2 sine theta over 2 cos theta over 2, you can replace it with sine theta. So that's just it. 1 minus sine theta divided by what? 1 plus sine theta. So reduction is very simple, but I don't like some of those stress. So let's just do it by the way. Now let's write it down before I clean the board. Let's write it down. We shouldn't spend more than an hour on math. 101. So after 101, we do after the assignment of 101, we do 102 assignment. Then we now come back to like normal class. Can I clean the board? Let me see. One thing I don't have in this life is writing. I don't like what I'm seeing. This writing is not fine, have you? God have mercy. Don't worry, I'll be better one day. Can I clean the board? Yeah, 2 minutes. 2 minutes. Let's be fast. I hope we can all see it. All those that are streaming online, can we all see the board? Most of them, they are asleep too. They are streaming on your bed. Asao. We can't see the board. Eh?
Maybe you write to me.
What did you say?
Maybe you just write in the middle.
I'm coming. Let me see if maybe if bending it can work. Orientation will lock.
Okay, 257.
Check it there.
Now.
No. I'm waiting for us to write everything so that I can clean the bottom. See, phone auto rotate. Check auto rotate. Let me see how it will look like. Okay, they said it's better now. Fine, thank God. Alright, you can follow up then. Can I clean it now? Can I clean it? Alright. Okay. I hope you have all written it. Some class rep down. Who is class rep here? They are part of those who want to submit tomorrow. Right? All their body do they shake. During my 100 level, there's no assignment I've submitted like before the due date. Me, I will count down, everybody will finish. Even I need to write my own last. Like I used to write assignment last. They all know me. I will teach everybody, they will write it, then I will now count down and be writing my own. So sometimes we will submit after the due date. Since I'm the rep, they will collect it. I've submitted assignments like 3 days to arrear before, 3 days after the due date. And two people were left behind. They told me that I should go and collect it, but they should give me akara money and all those kind of stuff. It used to crack jokes actually, but it can be very frank at times. Now, what's the second question? Show that what? Summation as k tends from 1 as k tends from 1 to n of k raised to power 4 equals to what? N into what? N plus 1, 2n plus 1, 3n square plus 3n plus abi minus 1. I try sha. I still found one correct. Over what? Over 30. That's the question, isn't it? Now you can solve it directly, but I would prefer that you do it like you first interpret this guy so that it can look so familiar with what we've known so far. So first interpret this guy. The meaning of this guy is that you are doing summation of discrete number like k equals to 1, 2. Whenever you see a sign like this, it's counting number, natural number. 1, 2, 3, 4, 5. Whenever you see this sign. So unlike this sign, this one now you are counting all real number. Like depending on the interval given to you. If I put 1 here and I put 2 here, all the real numbers between 2 and 1, like 1.01, 1.0, like continuous addition. This one now is discrete addition, like 1, 2, 3, 4, 5, 6, depending on where you are starting from. So now our k is starting from 1 is going to n. Now if k is 1, what will be this? 1, right? Since this means summation, then you add. If k gets to 2, what will be this? 2 raised to power 4, right? When k gets to 3, what will be this? But there's no time to write everything, just write dot dot dot. Are we together? When k gets to n, what will be this? N raised to power 4 equals to what? N into n plus 1, 2n plus 1, 3n square plus 3n minus 1 over what? So this is the question. Like this is the question. Either this or this, you can solve it. Though you can do this directly, but it's better you first interpret this aspect of this. Now, like I said, on the left hand side, what you are doing is summation. On the right hand side, what you are doing is substitution. For instance, what do I mean by that? If you say your n is 4, on this side you are doing summation of the first 4 terms. On this side you are doing substitution of 4. Like you just substitute 4 to wherever you see n. But on this side you are doing sum of the first 4 terms. If your n is 2, on the left side you are doing summation of the first 2 terms. On this side you are substituting 2 for n. So on the left hand side you are doing summation of terms. On the right hand side you are doing substitution of n. So now for your base case, you know, these assignments, not German, not OBJ. So all these notes you must write it out. Base case. Base case show that it is true for what? N equals to 1. So this should be the condition. N as element of natural number. Though they did not write it, but that should be the condition. Most cases, this is the condition given. So the base case that show that it is true for n equals to 1. Now if n equals to 1, that means on this side, that's the summation of the first term alone, right? Which is 1 equals to, let's put n here. 1 into 1 plus 1. 2 times 1 plus 1. 3 times 1 square, that's 3 plus 3 minus 1. 5, right? Over what? So here we have 1 equals to 2 times 3 times 5. 30 cancel 30, right? So 1 equals to 1. We conclude. The statement is true for what? N equals to 1. So we are done with the base case. Now the next step is our induction hypothesis. You write it out. Induction hypothesis. So what do we mean by hypothesis? Like an assumption, right? So we assume is true for a particular big number k to be precise. Assume it is true for n equals to k. If you have your time, you can test for n is 2, n is 3 if you love stress. But once you've done one and it's true, just move to the hypothesis direct. Are we together? Just 3 steps are okay. Base case, induction hypothesis, then your induction step, then you are done. Now assume it is true for n equals to k. We assume that k is a big number. So in this side, you are doing summation of the first k terms, which is going to include all the terms. The big number you are assuming here is including all the terms. Am I communicating? M total that girl. Now, assume it's true for n equals to k. Now, here we are doing summation of the first k terms, which is 1 plus 2 raised power 4 plus 3 raised power 4 plus dot 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 plus what? N raised power 4. But you put k there. K raised power 4 equals to what? N, which is k into what? K plus 1 into what? 2k plus 1 into what? 3k square plus what? Minus 1 over what? Over 30. Now you cannot move beyond this for k. There's nothing you want to solve again because there are missing terms here. Now, because you've written this expression out, then actually it's true for n equals to k. Your assumption is true in math. Any assumption in math, they are actually true. Now, assume it is true for n equals to k, which we've shown. Then you conclude that if true, now your induction step will now include if true for n equals to k. You know, initially you were assuming, but now you've concluded that if true for n equals to k, then show that it is true for what? N equals to k plus 1. Once you are able to show it, then the statement is true for all natural numbers of n. Are we together? So let's write this down so that I can clean the answer. I will give us 2 minutes to write everything. Just stop there because I'm going to clean everything all at once. I hope it's clear to that part. Are we sure? Can we all see the board? I hope we can also see it too. Yeah, I think it will be better now. It's kind of better. All these people don't sleep. So now don't sleep, Alvin. Okay, sure. Okay. I give us 2 minutes to write that before I clean it. That's number 2 of the 101 assignment. 2 minutes to write it. Or can just screenshot your phone since you are watching. You can screenshot and write it later. Like, have you sent any single mosquitoes? Yeah. So there's no mosquito at all. All those are just playing. Sure, they don't bite you. If you are TLT now, like 500 mosquitoes, you have seen their blood. Am I lying? All tech students here. Now find solutions to your lecture theatre. The place you are even managing, they lock it for days. But as you manage the telephone, mosquito in your that's why I love you. Imagine. Can I clean the board? Yes. We have 1 more minute. We are not going to waste time. After this, we have 1 left. 1 question left. The stress in this question is just the expansion of. Please don't sleep, oh. Because 102 is the. Who is the only 101 here? I know some girl. Like, raise your hand again. Only 101. Well, maybe when we are doing 102, Sleeping.
Yes, now.
So when we are done with 102, we are still coming back to 101 to treat some topics. But we just want to do the assignment first. Or you can be reading. We have not started our exam. We start our exam next month. My exam CV will start next month. Wonderful TDB, 10 p.m. to 5 a.m. every day. Is that bad? Can I clean it now? I can clean it. Sometimes we will be here. We have exam tomorrow, and like most of us would have, would have done whatever I want to do before we come for TDB. And as we are ending the TDB, we just walk straight to DLC. Last year were fun. Even physics 102 from that other room to DLC. Even math 102 101 from that room to maths department to NFL to our various centers. Now can we stop at where? No, let me write the case term first. 1 plus 2 raised power 4 plus 3 raised power 4 plus ... plus k raised power 4 equals to k into what? K plus 1, 2k plus 1, 3k squared plus 3k minus 1 over what? Over 30. Now we concluded earlier that if true for n equals to k, then show that it's true for n is k plus 1. Now, assuming k is 10, just assuming k is not actually 10. Assuming k is, assuming k is 9. K plus 1 will be what? 10, right? Then, summation of the first 10 terms rather, is going to be what? Summation of the first 9 terms plus the 10th term, isn't it? Like I say A, B, C, D. Summation of this whole term is going to give us summation of the first 3 terms plus what? The 4th term. So the summation, now we want to do summation of the first k plus 1 term. Because now we are saying n equals to k plus 1, right? So summation of the first k plus 1 terms, don't write this again, we've written it already. Summation of the first k plus 1 terms, which is going to first of all include summation of the first k terms. This, what I want to write next now is where you should start when you are writing. Which is going to be 1 plus 2 raised power 4 plus 3 raised power 4 plus what? ... plus what? K raised power 4. This is summation of the first k terms plus the k plus 1 term. All together is going to give us summation of the first k plus 1 term. Do we get? Like I said earlier, A, B, C, D. This is 4th term. Summation of this 4th term, this first 4th term, or let me add one more, EF. Now let's say summation of the first 4th term is saying now summation of the first 3 term plus the 4th term, right? Do we get that? Summation of the first 4th term equals summation of the first 3 term plus the 4th term. So summation of the first k plus 1 term is going to give us summation of the first k term plus the k plus 1 term. Is that clear? Like, we want to sum all the terms from the first term to k plus 1 term. Since k plus 1 is the next term after k, then it's going to give us the summation of the first k plus 1 term is going to give us summation of the first k term plus the k plus 1 term. Now, what's our k plus 1 term? We write it out in form of n, the last term in the question, which is what? N raised to power 4, isn't it? But now, what's our n? K plus 1 raised to power what? If this is the kth term, this will be our k plus 1 term. All this one is our first k term. Everything here is our first k plus 1 term. Of which our first k plus 1 term equals to first k term plus what? K plus 1 term. Are we together? Equals to k plus 1. No, from the question we have n here. Since our n is k plus 1. Then n plus 1, k plus 1 plus 1, that's what? K plus 2. 2n plus 1. 2n plus 1. 2 times k, 2k, right? 2 times 1, 2. Plus 1, 3. Then we have 3n squared plus 3n minus 1. So here we have this guy is going to give us 3 into what? K squared plus 2k plus 1 plus what? 3k plus what? 3 times 1, 3 minus 1, 2. 3 times k squared, 3k squared. 3 times 2k. You don't need to show all this. 3 times k squared, 3k squared. 3 times 6, 2k. 3 times 1 plus 3k plus 2. Yeah, so here we have 3k squared, 6k plus 3k, 3 plus 2. So you can just write it direct, don't need to show this word. I'm just writing out 3n squared plus 3n minus 1. If you expand it, you will get this. So that's that for that. Over 30, isn't it? Divided by what? 30. But we can't solve this guy because we cannot write all the terms out here. There are many terms, natural number. But even though you are going to count from 1 to 1000, those ones are even much enough. Now, but because we have an identity for this guy, you know this guy is equal to this, isn't it? And this is equal to this. Since this one has finite structure like this guy, so you can replace this guy with this, isn't it? So instead of writing this, you can write this because this is the same as this and this is equal to this. So here we have k into what? K plus 1 into what? 2k plus 1 into what? 3k squared plus what? 3k minus 1 over what? Some people used to forget that there is something left here. Please don't forget. Plus what? K plus 1 raised by what? 4. Equals to what? K plus 1, K plus 2, 2k plus 3, 3k squared plus what? 9k plus what? Over what? Over 30. Eh? Oh, sorry, over 30. Is that clear? So now let's find the LCM here so that the division can be under everything. So let's leave that guy for now. So this guy becomes k into what? K plus 1, 2k plus 1, 3k squared plus 3k minus 1 plus, you know the is what? 30, right? 30 in 31. 1 times this, you have this, right? Yeah. This over 1. 1 in 30, 30. 10 times this, you have 30 into what? K plus 1 raised by what? Raised by 4. Equals to this guy. Are we together? Yes. So now, okay, let's factor k because we have k plus 1 here. Let's bring it up. I'm focusing on the left hand side now. Let this one still be sleeping. Now, what do we have on both? What is common to both? So let's bring it out. Here we have k plus 1. What will be left here? K, alright? 2k plus 1, right? 3k squared plus 3k plus 1. Is that clear? No, if you use this to multiply this back, you get all this. Okay, sorry, minus 1. Minus 1. Is it clear to that part? Plus what? 30 into what? K plus 1 cube. You know, we already factor 1 out. We already bring this one out. So if you multiply this, you get raised power 4. So that we use big bracket now, showing that this is multiplying everything. Divided by what? 30. Now we have to open the bracket of everything that is inside. So let's just write it. I'll clean the board one more time to show that. So now let's write it before I clean the board. Okay, let's solve one more. I'm not writing this yet. I want to put this in here. So here we have k plus 1. Now k times 2k. 2k squared. K times 1 plus k Open bracket 3k square plus 3k minus 1. 3k square plus 3k minus 1. Then we have what? Plus 30 into what? K plus 1 cube over 30. Is it clear to that part? I just use this k to multiply 2k plus 1 to give him this. Then I wrote everything back. So now let's write it before I change the board. Should be clear. Please write very well. At least the 10 mark is like a bonus. What's time that this one is greeting good morning? It's kind of clear. I hope I have not slept. Should I have 1k? Like where is it? I use it to multiply 2k. Now become 2k square. K times 2k, 2k square. K times 1. No, it's k plus 1. I factored out. K plus 1. Can we see the board? We can see the board, Abby.
Yeah.
That is clear now. Active. Sharp. Some people have slept. Go to WhatsApp. Go and dialogue the group.
Yeah.
Help me to open the group, please.
How?
Go. No. She's an admin. Go to WhatsApp. Go and send message to your friend to join. Because we'll soon be done with. And I want everybody to be part of the complex number I want to solve next. Go to WhatsApp. Drop a message that everyone should join. They don't even need link. They should just come on my channel, come on my channel on YouTube and just check for the live stream. Are we done? Can I clean the board? Prepare yourself. We have not started. No, when last I've taught like this, that was my 100 level. This night 3 I used to be 6. Where's Maka? Okay. Yeah. Are we done? I'm remembering all those 100 level days. We buy sugar and pure water and share for everybody. Some people don't want to come, we beg them. Please come. It was funny actually. But then we were colleagues, like there was no senior, no junior. Like you now, you are like junior. But in those days, we abuse ourselves. There was no tutor, no student. We can abuse ourselves. We can abuse tutor self. Can I clean the board? I can write everything. We are good to go. Sharp. Blah 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 shit. Now, do you know why induction is like? Do you know why that if you can prove k plus 1? Do you know why it is true for the condition given to you? It's because now the k you assume is like a big number that like covers everything you've written already. You know, when we substitute k, it covers all the left hand side, isn't it?
Yeah.
Now imagine k plus 1. Like it's just like you saying I cannot put it now. There is a course we are doing 200 level physics 201 modern physics. Like what Isaac Newton proposed, like all this classical Newtonian physics, they are only like he said time is invariance, like time is independent, time is absolute rather. What do you mean by time is absolute? I just want to explain something here. What do you mean by time is absolute is because is that as you are sitting down here, as I am here, even though if I'm running, like the same time you will be counting, the same thing I will be counting. Are we together? Like if you are sitting down, even though we are on different frame, maybe I'm in a train or a train rather, or in a car, or even in an airplane, and you are sitting down. If I count 10 seconds in an airplane, you also count 10 seconds. Like time is the same everywhere. That's classical physics. But in special relativity, it's not true for speed of light. Like it's true if the speed is far from speed of light. But as you are approaching the speed of light, time is not absolute. For instance, if somebody is traveling with the speed of light, it can count 3 seconds and you are still counting 2 seconds. Do you get what I'm saying? So, and the Newtonian physics could not prove it for speed of light. It could only use that Newtonian physics for our everyday speed, like the normal speed, car and everything. The theory could not be proved for speed of light. So when Belloᵈḵᵈ came, that was when the man started the special theory of relativity. And when Belloᵈʰᵈ could prove all those stuff that we are talking about for speed of light, then he concluded that if true for speed of light, then it's true for everything. I know for the classical physics now, it's only true for velocity, our speed far greater than speed of light. But as v is approaching speed of light, all the classical physics, they are not true again, like they are false. Everything that Newton did, they are false. As velocity is approaching speed of light. So, but that's when this guy say t equals to t prime. That is why in another frame and I'm in another frame, we measure the same time. But this guy said t is not equal to t prime. Belloᵈʰᵈ said t is not equal to t prime, and was able to prove it too. And he said because how did he put it? The speed of light. Now under this guy, Isaac Newton was saying that velocity add up, that our u equals to u plus vt, u prime plus vt, or our u prime equals to u minus vt. But under speed of light is constant. C equals to c prime, regardless of the frame you are. Speed of light is constant. So this is only true for everyday speed. As you are approaching, speed of light is constant. But when Belloᵈʰᵈ concluded with this guy, then the equation he used was able to even prove all the one that Isaac Newton did. Whereas the one that Isaac Newton did could not prove for the speed of light. So we are able to conclude that if that statement is true for speed of light, then it is what? It is true for everything. So then, when the law of physics is saying that, there is a statement in physics that says the law of physics is the same thing everywhere. But for the Newtonian physics, it's only the same thing when the velocity is far from speed of light. But if we are now able to prove it that it's the same thing for speed of light, then it's the same thing for everything. So now what am I saying in essence? That sorry for taking it to 200 level. So now, if we are saying this thing is true for a bigger number than the whole thing you have written already, which is k plus 1, then it's true for everything, the condition given to you. Do you get what I'm saying? So you don't need to even know whether all the number given to you is, like, you don't need to know all the number. Since you already said the first k term, which include all your 1 plus 2 raised to power 4 plus 3 raised to power 4 plus dot 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 plus k raised to power 4. This already include everything, assuming that k is a big number that comprise everything, or that everything comprises whatever way. Now you are now saying you want to now show it for, let me just test k plus 1, like, let me see a number after, like, at least there should be something, at least there's life after life now, isn't it? So if you are able to show this, then it is true. You don't need to do anything again. So that's the powerful tools of mathematical induction. I'm just trying to just let you see like a glimpse of what induction is trying to show us. So now that's why, because you can be asking why k plus 1, then we conclude that it's true for all the statement. That's just like an idea of it. So now let's open the bracket. So here we have but that doesn't make Newton to be, Newton is still the greatest of all time, because all he did was in 1643 rather. There was no competition there. The man developed calculus that we are struggling with in Math 102 today. K plus 1 into what? Now we already have 2k squared times 3k squared. I've written this out. K plus 1. The open bracket. 2k squared times 3k squared. 6k4. 2k squared times 3k. 6k cubed. 6k squared times minus 1. 2k squared times minus 1. Right? Plus 30 into, if we expand this guy, we have what? K cubed plus 3k squared plus 3k plus what? 1. Binomial and Pascal. Write this thing 3 times in your notes. You don't know what we did and expand it together. Are we together? Like k plus 1, k plus 1, k plus 1, multiply it together, you get it. Over what? Over 30. Right? What all this one that we are doing, right? You know, we've left the right hand side, we are not touching it for now. All this one just LHS, write it on them. Left hand side, starting from, I think, the last one before this, write LHS on it. If you don't write LHS on it, you are doing another thing. So that they know that what you are doing is the left hand side alone. So here now we have k plus 1 no, I will still which one? Show this one. Oh, let's check. This times this times this times this. Okay, it remains this. K times 3k square, sorry. As it means the cosine. So here we have what? 3k cube, Abby. K times 3k. 3k square. K times minus 1. Minus k plus what? 30k cube. Let's expand this plus what? 90. You know, if you expand this guy is what? K cube plus 3k square plus what? 3k plus 1. So if you multiply by 30 times this, you have 30k cube. 30 times this, you have 90k square, right? 30 times this, you have what? 90k. 30 times 1, we have what? Plus 30. Over what? Over 30. Are we together? We are almost done with the left hand side. Just keep this one alone there. Since this one is already on the right hand side, so you don't need to touch it. Do we get? So just leave the k plus 1 alone. So here we can write this directly without writing 30 and this first. You can write this directly without writing this first. So here we have what? 6k4, 6k cube plus 3k cube plus 30k cube, 39k cube, right? Minus 2k square plus 3k square. That's k square. Plus 90k square. Plus 91k square. Minus k plus 90k. 89k plus what? 30. Everything over what?
30.
So we are done with the left hand side. This is where the left hand side stops. Are we together? Can I explain this down? We've written it earlier now. Now let's focus on the right hand side now. The RHS. Now the RHS. What's the RHS? K plus 1, right? Into what?
K plus 2.
K plus 2,
2k plus 3.
2k plus 3,
3k squared plus 9k plus 5.
Divided by what?
10.
Equals to k plus 1. So now let's see this guy. K times 2k. K times 2k. 2k square. K times 3. 2 times 2k. 2 times 3. Are we done? Okay, we are done. 3k square plus 9k plus 5. I hope it's not confused. Now, can we proceed? I only expand this, which is this. Then this one still remains. We can replace this with 7k, isn't it? 3k plus 4k is 7k now. So let's write it directly. 7k plus 6. Are we together? Can we proceed? So here we have k plus 1, open bracket, 2k squared times 3k squared. It's looking alike, thank God. 2k squared times 9k. 2k squared times 5. Now we move to the second one. 7k times 3k squared. 21k cube. 7k times 9k. 63. Okay. 63k squared. 7k times 5.
35k.
Now 6 times 3k squared. 6 times 9k. 6 times 5. Divided by what? Divided by 30. So equals to what? K plus 1 into what? 6k4. Are we? 18k cube plus 21k cube. That's 39k cube, are we? They are looking alike. Now let's move to square. 10k squared plus 63k squared plus 18k squared. It's 91, are we? Thank God. 91k squared. Let's move to k. Where's k now? 35k plus 64k. 89k plus what? Divided by what? Are they equal? Since the left hand, we start right hand side there. Since the left hand side is equal to the right hand side, so what happened? The statement is true for what? For n as element of what? Natural number. So that's that for that. Do we get it? So there are cases that you don't need to expand. You can factorize, and there's a way you factor and both sides will be equal. But you can't do it. This is like the quantity is like complicated, so you have to just expand both sides to make it equal. Most of the inductions that will be given to you, they're actually true. What they need is the proving. Are we done? No. So 3 minutes more. Maths is sweet now, I no go far now. Yeah, this number 2, we are just done with number 2 now. You are just done with number 2. All these people, they have gone to sleep. Be writing it to they are writing. Okay, you can. All those reps that used to be very, very vigilant. Yeah? Thank God for this refill. I for don't buy plenty marker like this. There's actually 111 students that bought it from me. They know what I need, so they dash me ink. They cannot dash me car. It was one of the best gifts I've ever received. This ink. The time I received gift most was last year during my birthday, December. In fact, I was given this bag then, this school bag. I was given like that birthday. I've not done it in my life before. Because it was very, very wonderful. They gave me wallet, they sent money, bag. Why did they not give themselves? Drinks, food. Somebody cooked fried rice, like correct fried rice and jollof. She sliced meat inside. It's 2 big meats. I'm not exaggerating. That birthday was very, very, very. People just sent 2K, 3K, 2K, 3K. They were just sending me money. I can't wait to do another one, Sha. I can't wait to do another one. Can I clean it? No. Very sweet now, isn't it? So normally I don't used to celebrate. Sometimes I'm doing birthday, you don't know. Yeah, let's be fast. Are we done? I'm not saying it so that if I'm being around, can send me money. I don't need to send me money. Can I clean the board? No, when my next birthday, I will be the one to. I will do something for you that you don't know. Money for don't day then. Yeah, let's be fast. There will be money then already. Yeah. Money is coming. Money is not the problem. But we build something bigger than money. 1 minute more, let's be fast. Are we done? Are we? So in the course of still writing this, let me be telling us more story about Isaac Newton. Well, Newton really tried, yeah, because he laid the foundation for modern physics. Without Newton, well, I can say Albert Einstein is actually a very crazy man. Like his brain is on this world, but Newton is still like, because during his time there was no competition then. 16 and all those achievements of Newton, like colors, Newton is the one who said like white light. If you point white light inside the prism, it's going to give like I think 7 or 8 different colors, like all those optics and everything. He's the one that all this calculus is the father of calculus. He was the one that started calculus. Like he wanted to prove one of these things, and mathematics could not prove him right. That's why he invented calculus. So that's why he invented calculus. He did a lot of things, and You know, all those things that Newton did, he finished it at the age of, I think, 24 years or 25. He started around 20 or 21 years, and I think he finished it around 24 years or so. Like somebody like me, imagine. Me, wait till I don't serve you nothing. Can I give you the word? Oh yeah, are we still writing? Basic about testing actually, his brain is beyond this world. That man, like, well, if I feel there, we get to another level, you know what I'm talking about. This one is very sweet. Which means any PhD student here? There's no PhD student. Physics, pure physics. Wow, you will enjoy another level. There is one course like this one, equation 127. We have improved since resumption. The last second test that we did on physics 201, we did not even see any calculation. Prove that all those physics 200 level, they are mad. Classical physics now, we don't even know where we are getting to again. Now we are done with that one. Now, number 3. Express sine of fifth power of theta as product of multiple You see all the board now. Okay, I think I caused it. I shouldn't have. Okay, let's go. So now we together before sign. So you need to find one of the same as minus I sine what? I sine theta. We actually do just now let me just leave it for us. You don't need to prove it. But let me start. If your z is this, then this one over z. Can write it direct, don't be proof, but let's quickly prove it. If z is this, then 1 over z will give us 1 over what? Cos theta plus what? Sin theta. Multiply by the conjugate as if you are rationalizing. Rationalize is not as if. I sin theta over what? Cos theta minus what? I sin theta. So you know this like difference of t square, isn't it? Like a plus b, a minus b. So if you use this to multiply one, what do you get? Cos theta minus what? I sin what? Theta. So difference of 2 square, a plus b minus b same as a square minus b square, right? So here we have a square cos square theta minus what? I square sin what? Square theta, right? So here we have what? You don't need to write this in the solution. Just keep your pencil. You are not using anymore. So this guy give us what? Cos square theta minus what's I square? Minus 1. Do we know that? So what? Sin square theta. 1 times minus 1 plus. So this one give us cos square theta plus sin square theta. What's cos square theta plus sin square theta? So cos theta minus I sin theta over 1 is what? Cos theta minus I sin theta. Is it clear? So that's just that 1 over z. All this no rationalize, don't worry. Or you just know that I'll make sure that I can put it again. If z is cos theta plus I sin theta, it's only valid. This is only valid for complex number. Cos theta plus I sin theta, then 1 over z equals cos theta minus I sin theta. Assuming this question is in plus, we add. If it is cosine, we add. But if it is sine, we subtract. Then you see why we are subtracting because it's sine. Now z minus 1 over z equals to cos theta plus I sin theta minus cos theta minus what? I sin what? Z minus this give us this minus this, isn't it? This cancels, isn't it? So minus times this, it cancels. Minus times minus plus, right? I sin theta plus I sin theta. 2I sin what? Sin theta. So z minus 1 over z equals to what? 2I. Do we get it to that part? Huh? Oh yeah, that person that said no. Which part did you not get? Huh? From the start. We are given this. If this is this, then 1 over z is this. Why are we doing 1 over z? Because we need sin theta now. And that's the only way we can get sin theta. We need this sin theta. That's the only way we get sin theta is to find the reciprocal of this, then subtract them so that we can give back to sin theta. Are we together? Assuming it's cosine, then we'll be needing cosine here. So instead of subtraction here, we do addition. If we add this guy, this one will cancel, it remains cos theta plus cos theta, which is equal to cos theta. Do we get that? But since it's sine, we subtract. Am I communicating? Are we together? Don't get it off. This is the only way you can do it. Now, the next thing now is that since our question has a power of 5, so we have to put this to power of 5. Let me write it. So this guy gives us 2I sin theta to power of 5 so that you can give birth to the question back. So if you take a fifth power of this, we have to do same thing with this, right? So that the question will not change, isn't it? Are we together? Are we together? So then as this one now becomes what? 2 raised to power 5 I raised to power 5 sine what? Is that clear? This one now, 5. 2 raised to power 5, I raised to power 5 sine fifth power of theta. Do we get into this part? Now we have to expand this guy and say it is equal to this. Am I communicating? And don't forget, for De Moivre's theorem, if is this line showing? Let me confirm. Is the line showing?
Okay, yeah.
It's showing, man. Let me write it the other way. So please, if you don't get it and you also here, please pay attention again. I want you to like write everything. This is the last question. So here we have sine of theta. So whereby z equals to what? Cos theta plus what? I sin theta. Then 1 over z will give us what? Cos theta minus what? I sin theta, which are proved, or you don't need to show the proof. So now z minus 1 over z give us what? Cos theta plus I sin theta minus what? Cos theta minus what? Theta equals to what? 2I sin what? Because this cos minus cos will cancel cos. Now minus times minus plus. Now I sin theta plus I sin theta, you have 2I sin theta. Now if z minus 1 over z equals to 2I sin theta, then z raised power n minus 1 over z raised power n will give us what? 2I sin what? N theta, according to De Moivre's theorem. Are we together? If this one have power of n, then the theta will be multiplied by n. That's De Moivre's theorem. We are coming back to this before. I just stated at the initial state now. We don't need it now. So now, since z minus 1 over z is this, then how can we, at the end of the day, we need something that we can write in form of sine fifth power of theta equals to this, right? So now, how can we turn this one to our sine fifth power? It's by taking the fifth power of it. This one now will give us z minus 1 over z raised to power 5 equals to what? 2I sine what? Theta raised to power what? So that if you take the fifth root of both sides, then we have the question back inside this guy. Then here we have what? Z minus 1 over z raised to power 5 equals to what? 2 raised to power 5, I raised to power 5, sine what? Fifth power of what? Theta. Are we together? So here we have z minus 1 over z equals to 32I sine fifth power of theta. No, I raised to power 5 is r. Do we know that? I raised to power 5 equals to what? I square all equals to I raised to power 4 times r. Agree? Equals to I square all square times I. Agree? What is I square? Square times I minus 1 square equals to what? R. So I raised to power 5 equals to R. So yeah, we have this guy to be equal to, sorry, this raised to power 5. Are we together? Do we get into this part? So we need binomial theorem to expand this guy. Binomial theorem. So at the end of the day, when we expand it, we now see something like this. Now can I be bringing this in? Now if we expand z for binomial theorem, note. Let me do it here. Let's write this so that we now apply it. If you have a minus b raised to power n is what? A raised to power n minus n a raised to power n minus 1d. This over 0 factorial over 1 factorial plus it will be plus minus plus. If this sign is minus, you have plus minus plus minus plus minus. Then here we have what? N into the power will come down n minus 1 a raised to power n minus 3 b squared over 2 factorial minus n into n minus 1, n minus 2, a raised to power n minus 3, b cubed over 3 factorial plus n into n minus 1, n minus, you don't need this in what you are writing. This is the formula for binomial. I want to apply it. You don't have to write it in the solution. N into n minus 1, n minus 2, n minus 3 will also come down. N minus 3, a raised power what? N minus 4, b raised power 4 over what? 4 factorial minus n into n minus 1, n minus 2, n minus 3, a raised power what? N minus 5, b raised power 5 divided by what? 5 factorial. 1, 2, 3, 4, 6. We've already gotten since our power is 5, so let's stop here. Are we together? Can continue expanding plus dot dot dot, but let's stop here. It's our power 5. Now let's begin to apply this. Now our z is like a now, isn't it? Our 1 over z is like b. So if you have to expand this guy, we have what? Z raised to power n. What's our n? 5. 0 factorial over 1 minus n 5 into what's our a? Z. N minus 1 is what? 4. Right? What's our b? 1 over z. You don't need to put in minus again. Because of this minus, that's why we are having plus minus plus minus. Are we together? So 1 over z over 1 factorial plus n, what's our n? 5. N minus 1, 4. What's our a? Z. Raised by n minus 2, 3. Our b, 1 over z square. That's 1 over what? Z square. No, it's 1 over z all into square, but 1 square is also 1. Are we together? Let me to wake up. Over what? 2 factorial, which is something as 2, isn't it? Plus minus plus. The next one is negative. We have n 5 into 4 into 3 z square 1 over what? Z cube divided by what? 6. 3 not 3 or 3 factorial, that's 6. Right? Plus minus, then the next one is plus n multiplied by 4 multiplied by 3 multiplied by 2 a, that's z raised to power 1, 5 minus 4, then b 1 over z 4 divided by 4 factorial. What's 4 factorial? 24. Then the last one minus 5 into 4 into 3 into 2 z 5 minus 5 is 0. Z raised to power 0 is done. Right? Then we have b raised to power 5. 1 over z raised to power 5, right? Divided by what? 5 factorial equals 120. Don't forget this is equal. Equals to what? 32i sine what? Fifth power of what? Theta. Let's write it down so I can do this. Don't write this, you don't need this. You're only applying it to this. You can just expand. And I will show us the simple way to expand without even writing this out. Like very easy. Don't stress. Just write it first, then I'm not sure. I will still rewrite this first. I want it to be on a straight line. So write like this, then right. But all these are on a straight line, these two together. Like this. Then equals to 32i sine fifth power of theta. Hello guys, are we following? Are we following? Sharp, okay now. It's getting clear. Abi, it's clear. It's clear. Okay. Boss man. All right. All right. You can just screenshot it. They are writing it before I clear the board. So you, this guy is serious. Somebody said everywhere. I have any answer. Everywhere looks like board. Ah. I'm just playing with. I love to play. I'm just playing. Are we done? There's a guy there who say was being the part. Do you know? Is it the rest? That guy is really. I don't know. I don't know. But I used to do my move then before the I used to get good stuff. Uh, this actually have some titles now. You guys are doing. But let me. Is one of the hardest courses in the world. I think chemistry should be number one. Chemistry is harder than anything. Don't say the answer. You can't study pure chemistry. You know that there is every. Can I clean the board? Kenya is rated than MBS in terms of hardest course in university. I even think English is even rated more than MBS. So it got to a point even writing 200 levels. When we were doing modern it was like, I was like, shit, I didn't know that is your answer. I will still in this world together. Because there are things that they will be saying, be like, child and Gosha, let's continue learning them. No problem. But those things are actually true. I'm not even talking about all this philosophy like this one talking of like our physical was things that can actually true about our physical world, but they don't believe in it anyway. So unlike philosophy, that philosophy is another thing. You get to another level, you do philosophy. Yes, it's one of them. All those lies. Can I do the board? I'm doing bandit. I'm doing magic. Tell him to do magic now. Do magic too. Oh, just screenshot. Write it. Don't worry. But this thing no go far now. Say it go far. Binomial. Okay, don't worry. I will continue from this part. I believe it will no longer be magic. Can I tell you about testing? It got to a point about testing mistake was even found to be true. Yes, there was a time was like the earth should be either expanding or contracting. But he couldn't prove it was like it should be a mistake, maybe. But when he had died, like many years that he had died, scientists later discovered that yes, it's expanding. It's one about the testing mistake there was even something like that. Guy is really crazy about it. Guy is crazy. ST is crazy. Can I clear it? Yeah, we are slow right now. When I was suggesting, I was faster than this. Sorry. So now listen. I will start from here. Don't forget, this is the initial condition. Z minus 1 over Z equals to 2. If Z minus 1 over Z equals 2I sin theta, then Z raised power n minus 1 over Z raised power n equals to what? 2I sin what? N theta. Right? So now here we have Z minus 1 over Z minus 1 over Z all raised to power 5. Now let's expand again. You don't need to write it, written it. No, all raised to power 5 is equal to this. We showed it earlier, right? Now in binomial theorem, Z raised to power 5 plus Z will reduce by 1. The first one you only have your first part. This one will have power of 0 here. So the next one Z will reduce by 1. Then this one we have power of 1 over Z. The next one, since it's minus, we have plus minus plus minus plus. The next one Z will also reduce by 1. Then this one will carry square. Are we together? Plus minus plus, the next one will be minus. Z will also be reduced by 1. Then this one will carry cube. Plus Z will be reduced by 1. Then this one will carry fourth power. I think there's one left. Z will now be reduced totally, which is Z raised to power 0. Then this one will carry what? Fifth power. Then we need the coefficient. No, we have not obtained the coefficient. Now we can obtain the coefficient using Pascal triangle. If you have A plus B or A minus B, whatever, raised power of 0 is what? 1. If it's power of 1, what do you have? If the power is 2, what do you have? If the power is 3, what do you have? 1, 3. If the power is 4, what do you have? 1, 4, 6, 4. If the power is 5, what do you have? If the power is 5, you have 1, 5, 10, 10, 10. So this is just the expansion. Don't need to stress on it. So that's the expansion of this. Do we get? So all this one will be reducing by 1, then this one will be increasing by 1. Once this one has reduced to the end, and once this one has increased to the highest power end, then we use Pascal triangle to obtain the coefficient. 1 over Z5 equals to what? 32I, right? Sin what? Fifth power of theta. Which one? This one. I don't get it. Show this one. Z raised to power 4. It should be what? I don't get the question. What is it? Yeah. Is this second one? This one will be reducing. This first Z. Z5, Z4, Z3, Z2, Z1, Z0 here. This second one will be increasing. No, here now, there's no second one here. That means it's power of 1 here. So yeah, power of 1, power of 2, power of 3, power of 4, power of 5. This one will be reducing, this one will be increasing. Just like you have A minus B raised to power 5. A5, then A4, A3, A square, A1, A0. Then here you have B0, B1, B2, B3, B4, B5. Do you get? So that's what we did here. Now, what are we going to do now? Let's gather all those stuff together. So here we have Z raised to power 5. We've written this earlier. We don't need to rewrite this step. Z raised to power 5. Bring this one to it. 1 over what? Z raised to power 5. Are we together? Please let's look there. You know, here we have Z4 and Z. So these are the denominators. It can cancel one out of it. So here we have minus 5Z cubed, isn't it? Now let's check. This also can have cube. So Z can remove 1 from this. And this one will be what? Plus 5 multiplied by what? 1 over Z cubed. Am I right? Do we agree? Eh? Z here 1, Z here 3. So yes, this Z will go. You have 3 left here. 5 times 1 over Z. Z cubed. 5 times 1 over Z cubed. Then here we have Z, this Z square. If you remove 2 from here, it will remain 10Z. Agree? So this one will be minus what? 10 times what? 1 over Z, right? Abi? Equals to 32I sine 5 power theta. Do we get that? Are we together? Hey. Let's talk now.
Yes, sir.
If you are together, let's go. If you are not together, talk. So this guy gives us Z raised to power 5 minus 1 over Z5. What is common to this? Bring it out. This one will be left with what? Z cube minus, no, there is minus times minus plus. So don't mistake it to be minus now. So minus is already outside. 1 over what? Z cube plus 10, right? Z minus what? Equals to what? 32I what? Sine 5 power. Then theta. Are we together? Now don't forget the Movet's theorem that if you have Z minus 1 over Z to be 2I sine theta, then Z raised to power n minus 1 over Z raised to power n equals 2I sine n theta. So our n here is like 5. So this guy is equal to what? Theta. So if you want to, because this is the question, if you want to make this guy the center of formula, what do? We divide both sides by 32I, right? So here we have sine 5 power of theta equals to 2I sine, this is 5 theta, sorry. 2I sine 5 theta minus 10I sine 3 theta plus 20I sine theta over what? 32I. Is it clear to that part? Eh? So now sine 5 power of theta now give us, you know, since they have the, you can distribute the denominators to each term. It can be this over 32I, this over 32I, this you can write them separately like that. So if you have A plus B plus C over 2, same as A over 2 plus B over 2 plus C over 2. So 2I sine 5 theta divided by 32I. I will cancel I. You have 2 over 32, which is what? Sine what? 5 theta minus 10I over 32I. That's 10 over 32, which is what? 5 over 16, Abi. Sine 3 theta, right? 20 over 32, I cancel I. That's what? 10 over 16, Abi. Like 116, 15 to the common. Are we together? Is it clear? So here now we now have sine 5 power of theta equals to what is common to both of them, to everything. So if you bring around over c, you have what? Sine 5 theta minus 5 sine 3 theta plus what? That's the answer. So this guy is equal to this. Even though you have to integrate this guy, which is very complex, unless you use reduction formula. Even in that process, you can still count because it is long. You can use complex number to break it down. It's very easy to integrate all this now. So complex number is even like an F in calculus integration. So this is the answer. This guy is called this guy. You can plug in any value for theta. This will become to this. Assuming your theta to be 30, plug in 30 here, 30, 30, 30 will be equal. Now assuming it's cosine, all these one would have been plus, plus, plus. You still have the same answer, but here will be 1 over 15 cos 5 theta plus 5 sin cos 3 theta plus 10 cos theta. So you don't have to do it. Is it clear? Is it clear? Is it clear? So now let's write it. Let's write it. Is it clear, guys? But I've explained the binomial expansion. Huh? Those of us that are watching from online, did this thing come? Okay, all right. Medis, you just come online. We are not 102 like that. Oh. Yeah, let's write it so that we can start 102. Maybe you have to stretch your leg because all these ones are very simple to what we are about to do now. Do you understand? The mistake I made is I forgot to bring the. That's a terrible mistake you can ever make. Not to have Gary at home, or not to take Gary to where you want to take Gary. Gary, if you have every food in this life and you don't have Gary, forget. You don't have anything yet. I have to open my phone back and check me out my book. Man, go on my lap. Eh? Who? Say medics. No check it. Check your DM now, medics. Everything dey there now. Broadcast. Cannot see. You cannot see it. Are you not seeing it there? I don't know. I think it's clear a bit. But why is the house screen like this? Abi is on your phone. I don't understand why it's house screen. Hey, Can we see the board now? What of now? Can we see the board now? Is it clear now? Medics, Paul, is it clear now? It is better. Okay. Uh, uh, uh.
This side now.
Let's start. We start 102. What time now? So we start 102. Are we ready? Yeah. Let's fresh one. Let's fresh one. Let's fresh one. Okay, let us say we use 2 hours for man. Even me, I'm afraid of that one. That's less. Go and stretch for 5 minutes. Oh. Yeah, with Gary, use this time to drink Gary. Yeah, with Gary, the 5 minutes to drink Gary. Let's not make mess. They are reading in the other room. Our exam finishing now. I will be using laptop.
So, someone there. Side. Mouse.
This like yeah, just everything is just like simple. Just minus. You are instead, right? You are instead. You are seeing your face is very, very, very fast. We are starting 102 very soon. No, we have not started 102. We just want to give like 5 minutes break. I'm coming. I quickly want to check WhatsApp. You guys just wait. I'm coming. Just give me a few minutes.